Good morning. Welcome to chemistry quiz number 3. In this, we'll solve the questions asked in Staff Selection Commission, TNPSC, UPSC, NEET, JEE, etc. Let us see the first question. Monazite sand is an ore of dash. Monazite sand is an ore of thorium, especially lanthanides, actinides. What is the chemical present in nail polish remover? Acetone. Acetone is used to remove the nail polish. It is also one of the highly used solvent for dissolving organic compounds. What is the Van Gogh factor I value for weak acid dissociation? I equal to, for weak acid dissociation, I equal to 1 plus alpha, where alpha is the degree of dissociation. Let us see how this Van Gogh factor is obtained. For weak acid, it is partially ionized. At time t equal to 0, let us take 1 mole of weak acid. At time t equal to 0, H plus A minus won't be there, 0, 0. After a certain time at equilibrium, a fraction of acid dissociated, that is alpha, a fraction of the weak acid dissociated, that is alpha. So 1 minus alpha is the remaining concentration at equilibrium. Alpha is the concentration of H plus at equilibrium. A minus is the alpha is the concentration of A minus at the equilibrium. Now, total number of ions. How many ions are present? Total number of ions is equal to 1 minus alpha plus alpha plus alpha, that is 1 plus alpha. Now, what is I? I equal to total number of ions divided by total number of moles before dissociation. What is the total number of moles before dissociation? 1. Total number of ions at equilibrium? 1 plus alpha. Therefore, I equal to 1 plus alpha by 1. So, 1 plus alpha. If you know I, one can easily calculate the degree of dissociation. Alpha equal to I minus 1. Okay, let us see the next question. Which base is used as an antacid? In antacid, this is used for acidity. What are the chemicals present in antacid tablet or antacid tonic? It's a mixture of magnesium, calcium, aluminum hydroxides. They are basic. So it neutralizes acidity in our stomach. Give an example of anthraquinone dye. Give an example of anthraquinone dye. Alizarin. Alizarin is an anthraquinone dye. It gives red color with the aluminum 3+. This is used as a reagent to confirm aluminum presence in the salt in qualitative analysis. In human body, carbohydrates are stored as. In human body, how are carbohydrates stored as? The answer is glycogen. In plants, carbohydrates are stored in the form of starch cellulose, whereas in our body carbohydrates are stored as glycogen. It is synthesized in liver and muscle. Which carbohydrate is the sweetest? Which carbohydrate? Honey sugar, fructose. Fructose is the sweetest carbohydrate. Among all the carbohydrates, it is the sweetest. Fructose is the sweetest. It is present in honey, fruits, etc. Mutarotation does not occur in dash carbohydrate. Mutarotation does not occur in dash carbohydrate. It is sucrose, whereas all others are reducing sugars. Sucrose is a non-reducing sugar. There is no free CHO group or CO group because it is involved in glycosidic linkage. How many nodal planes are there in 4D orbital? How many nodal planes are there in 4D orbital? The answer is 2. What is nodal plane? It is a plane where there is no electron density. Where there is no electron density. It is a plane where the electron density is 0. For s orbital, it is spherically symmetrical. So, it has 0 nodal plane. For p orbital, there is only one nodal plane, that is perpendicular to the two lobes. For d orbital, there are two lobes. They are the planes passing in between the lobes of the d orbitals. In the case of f orbital, there are 3 nodal planes where there is 0 electron density. Let us see the 10th question. Which is the most electron affinity element in the periodic table? Which has the highest electron affinity value? It is chlorine. Fluorine is the most electronegative element, whereas chlorine is the... In fluorine, when you add one electron, there will be interelectronic repulsion. As a result, it is highly energetic, it is unstable. Fluorine cannot accept easily an electron, whereas in chlorine, it can accept an electron because of the presence of the d orbitals, because of the presence of the vacant d orbitals where electron can delocalize. So there is no interelectronic repulsion in chlorine, whereas in fluorine, addition of an electron affinity is nothing but the energy released when an electron is added to a gaseous atom to form gaseous ion. In the case of fluorine, when an electron is added to the atom, gaseous atom, the atom is so compact, there will be interelectronic repulsion because of the added electron. Water gas is a mixture of carbon monoxide plus hydrogen. It is one of the highly best fuel. It has the highest calorific value. What is the Van Gogh factor for benzoic acid association? For example, acetic acid undergoes dissociation, whereas benzoic acid undergoes association. It forms especially dimer. In that case, I equal to 1 minus alpha by 2. For acetic acid, I equal to 1 plus alpha, where there will be dissociation. Okay, let us see how this formula is obtained. Let us take formic acid, benzoic acid. It undergoes association. For example, if it is benzoic acid, you can put 2 here, you can put 2 here. If it is some other acid, then it may form trimer, tetramer, pentamer, etc. So let us write at time t equal to 0, the benzoic acid concentration is 1 mole per liter, or you can put C mole also. Okay, now at time t equal to 0, there is no association taken place, so HAN equal to 0. At time equilibrium, a fraction of the benzoic acid undergoes association. A fraction of the acid or any solute undergoes association. Therefore, alpha is the fraction of solute associated. Therefore, the 1 minus alpha is the remaining at equilibrium. So this will be 1 means alpha and alpha by n. Okay, you can also put C, and here C into 1 minus alpha outside C alpha by n. You will get the same formula at the end when you calculate I value. We'll see now. See now, what is the total number of ions at equilibrium? So 1 minus alpha plus alpha by n. For dimer, let us write for simplicity here 1 minus alpha plus alpha by 2. So 1 minus alpha by 2. Okay. Now, what is Van Gogh factor? That is total number of ions at equilibrium at T divided by total number before dissociation. See, in this case, we have taken 1 moles per liter. Suppose you have taken C moles per liter, then you can put C here. So C will get cancelled. You will get the same formula as if you put 1 moles per liter initial concentration, or C moles per liter, you will get the same I value, because C will be here, cancelled. So total number of ions at equilibrium 1 minus alpha by 2 divided by total number of moles before association 1. Therefore, I equal to 1 minus alpha by 2. Let us see the next question. It is commonly asked in various competitive examination. The spin magnetic moment of cobalt in HgCO SEN 4 times is. This compound is very important compound, used as a standard for magnetic susceptibility measurements. This is a standard substance which has a very good spin magnetic moment value. So in this, they have asked the spin magnetic moment of cobalt. Yes, it is square root of 15. Okay, let us see how this value is obtained. In this Hg2 plus, mercuric ion is diamagnetic because it has D10 configuration. The central atom in this coordination complex is CO2 plus, and SCN, this is monodentate ligand, SCN minus. Okay. What is the atomic number of cobalt? It is 27. So 3d7 4s2. Since CO2 plus, the 2 4s electrons are lost. Let us write the electronic configuration. As you see, 7 electron. The 7 electrons are accommodated. There are 3 unpaired electrons. N equal to 3. There are 3 unpaired electrons in this complex. Now what is the formula to calculate the spin magnetic moment? Mu equal to square root of n into n plus 2. Therefore, n equal to 3. Let us substitute n equal to 3 in this formula to get square root of 15. Okay. Next question. Shall we move to next question? The percentage of nitrogen in urea is. What is the percentage of nitrogen in urea is? Urea is one of the best fertilizer which has high nitrogen content. It is 46.6%. How do you calculate this? How did you obtain this? Let us see now. The formula of urea is NH2CO NH2. What is the formula to calculate the percentage of nitrogen? Percentage of nitrogen is equal to weight of nitrogen in this urea divided by molecular weight of urea equal to 14. There are 2 nitrogens. 14 into 2, 28. Molecular weight of urea is equal to sum of the atomic masses of the various elements present in the urea. So it is equal to 60. Percentage, so into 100. Why do you put 100 into 100? Percentage, because in the question they have asked to calculate the percentage of nitrogen. So that is equal to 46.6%. Let us see the next question. How many milliequivalents are in 20 ml of 0.2 normal HCl? How many milliequivalents are present in 20 ml of 0.2 normal HCl? It is 4 milliequivalents of HCl. How it is obtained? Let us see now. Number of milliequivalents of HCl is equal to N1V1. Okay, according to law of volumetric analysis, N1V1 equal to N2V2. 1 milliequivalent of acid will react with the 1 milliequivalent of base. So number of milliequivalents of base is calculated N into V1. So number of milliequivalents of HCl is equal to N1 is 0.2 into volume 20 ml, so 4. The next question is, calculate the volume of 1 mole of ice. What is the volume of 1 mole of ice? Given the density of ice, as you see, the density of ice is 0.9 kilogram per liter and water density is 1 kilogram per liter. It is given in kilogram. Okay. So ice has less density than water. So ice floats on water. Why ice floats on water? Because it has less density than water. Suppose it has more density, then it won't float. The answer is 20 ml or 20 into 10 power milli means 10 power minus 3 liter in terms of liter. Let us now see how it is obtained. 1 mole of ice, 1 mole of water, weight equal to 18 gram per ml, or 1 mole of ice weighs 18 gram. We know density is given, density equal to weight of ice divided by volume of ice. So the volume of ice is equal to weight of ice, that is 18, 1 mole of ice we have taken, divided by its density, because can cross multiply here 0.9, therefore 20 ml or 20 into milli means 10 power minus 3 liter. Let us see another important question. When ionic product is greater than solubility product, then the precipitate dash. Ionic product is greater than solubility product. That means Q value in the previous problem I have solved. Please see reaction quotient. Ionic product is nothing but Q. Okay. Solubility product is nothing but K value. Equilibrium constant. This is Q. This is greater. Q is greater than K. In that case, ionic product is greater means product is greater. Okay, the product ions are greater. Therefore, it will reverse, shift in the backward direction. More precipitate will be formed. Okay, this is simply based on Q value and K value. This is Q and this is K. There are three cases. We have earlier solved a problem in chemical equilibrium. Please see that. So, the precipitation occurs, then more precipitate is formed. Suppose if ionic product is less, then the precipitate will dissolve. Okay. Suppose ionic product is equal to solubility product, then there will be no reaction, there will be no change. Okay. Let us see the next question. Find the turnover number of the enzyme. When 1 mole, 1 into 10 power minus 6 moles of enzyme produces 0.6 moles of product per second. What is the enzyme concentration? Enzyme or biocatalyst, they are used in very low amount. Catalysts are used in very small quantities. So this is very small, and the products 0.6 moles of product formed per second. What is turnover number? The answer is 6 into 10 power 5 per second. Let us see how it is solved. According to turnover number, it is defined as the ratio of moles of product formed per second divided by moles of enzyme. That is, how many moles are produced per 1 mole of the enzyme. How many moles are produced, products produced for 1 mole of enzyme. That is called turnover number, 0.6 moles per second. Okay, product formed divided by enzyme concentration, 1 into 10 power minus 6. So 6 into 10 power 5. If you bring it here, 10 power 5 per second. The next question is, what is the unit of K? Rate constant. What is the unit of rate constant for zero order reaction? The answer is moles per second. How this is obtained? Let us see now. Let us consider A is converted into P, product. A, reactant, is converted into product. The rate of the reaction is written as, we can write easily the rate of the reaction in terms of disappearance of A. So minus disappearance, minus sign, appearance means plus, minus dA by dt equal to, that is rate. The rate of disappearance per second of rate of decomposition of A per second is equal to rate, equal to K into concentration of A. In this case, it is given a zero order reaction, therefore 0, A power 0. For first order reaction, 1. For second order reaction, you need to put 2 here. Okay, so A power 0 equal to 1. So rate equal to K. Now this is change in concentration, mole. Okay, change in concentration, mole. What is time? Decomposition of A per unit time. So what is the unit for time? Second. What is the unit for concentration? Mole per second. That is equal to K. Thank you guys for watching.